Hello and good morning, and thank you so much for joining me here in my shop on October 21st, 2024 for I think it's day 2 on this radio, and today is going to be about changing some capacitors, in particular the power supply filter capacitor. So when I turned this radio on, all I really got out of it was an ugly hum, and so first thing you want to be suspicious of it, this guy here for sure. Especially these ones that are not, not in a metal can on the radio. They're this type. They don't last too long, and often these are replacements themselves. This thing's already been through one of these. Well, I don't know that about this radio. Let's put it like this. So I did mention this special capacitor, or what appears to be a special capacitor. Actually, two of them together here. Maybe this isn't even a capacitor. I don't know. We'll have to find that on the schematic when we get to it. And I mentioned the Hunt's type capacitor here. This may be a replacement. Hard to say for sure. And there's another one down here, a Plasticele capacitor, different than these others. These are typical wax capacitors here. There's a few of them in there. So somebody's done something down here. I'm not sure. This is the guy we're going after. This could be a replacement, or it could be the original. The way I like to do it is I cut the wires and maintain the wires and utilize the wires in putting in the new capacitors. So I got to get all that out and get going on it. If you've watched lots of my videos, you've seen me do this many times, but if you haven't, this is the method I use to replace something like this. This is two capacitors here, so I have the two replacements here. Twisting together the negative wires, leave the positive ones sticking out. Okay, now we look to see where we can put this. Well, this has left a big space inside the radio, so there's actually lots of space here. So these can just sit in here anywhere. I would like to tie them down somehow, but often there's really no way to do that in a decent way. Anyway, so there are some slots here. Could put a tie wrap through. Oh, it's a little tight in there. Yeah, it looks like it's made for the metal band that was around. Was there no metal band on this? I don't think there was. So I think originally there was a metal band that went through the slot and looped around one of these guys, and this is a replacement, I'm guessing. Is there any way to tell? I don't know. It's pinched here, like it's been in a clamp. Or did I take it out of a clamp and I just forgotten about it? I think it just fell out. That's how I remember it. Okay, so it looks like we don't really have a chance to strap these in easily. So what I may do, instead of using this wire, I will solder the negatives right onto a terminal, and that'll hold this down a fair bit. Right onto this terminal here. And then I need the red wires to come over. Good, let's cut this out here. Just leave lots of wire for now. I didn't leave a lot of wire. What a dummy. And this practice of making everything just a little too short. No, that'll be fine. So what I'm going to do, I'm going to connect the two positives. just be quiet here, I'll work a little faster. I like to put this right up close to the capacitor body. Broke a little soldering rule there. Anybody catch it? Put my hand underneath the thing I'm soldering. Don't put your hand underneath it. No, that's not a good idea. Get rid of this excess wire. Same thing on this side. Nice and close. Don't put your hand under it. Okay, get rid of the excess wire again. There we go. Now this guy. I did not figure something out here. Go in like that. Just be sitting like that. That would work. That'll work. Here and leave a little bit. Okay. And so that little bit of wire I left I can use now to kind of lock down the new wire. Push this down here. Okay, those capacitors, they're not going to go anywhere. Good. Okay, job done. We can try this radio again. Let's see if it works this time. I'll often get a very surprising result from just changing the filter capacitor on one of these guys. Okay, I'm going to go drink a little coffee, then we're going to turn it on. Okay, I think we're ready to give this guy a go. So, hey, you're listening to shortwave radio, are you? Listening last night or yesterday? Up high, 28 megahertz. The high frequency bands like 11 meter band for ham and CB and all that stuff is just flying. I listened to CB guys talking, probably neighbors, talking to each other casually on their CB radios. I don't think they had any idea There's somewhere in the southern states that I'm listening up here in Canada to what they're saying, and just they're not those screaming crazy guys, just ordinary people, ordinary CB radios, and like I say, the ham radio thing's just going wild on 10 meter on the 10 meter band. So anyway, okay, but this is definitely not the 10 meter band. Now, let's see what happens here. So I'm going to flip this on. Having worked on the power supply capacitors, if I made a mistake, it's a big deal. So I'm definitely going to use the dim bulbs to start it up. Did I make a mistake? No, I didn't make any mistakes. Here we go. Okay, so I have both. You didn't quite see them. I have both bulbs screwed in here, and neither one lit. There isn't enough power draw to light either of these bulbs. And we're operating with only 90 volts because we're turned down on the knob here. Let's go up a little higher. Maybe up around 100. Hello, radio. Oh, I hear it. Now we're operating on this bundle of wire as an antenna, and this is probably helping a bit, just having it nearby like that. Let's just tune around and see what happens here. So you hear this sound? Hear the tuning sound coming in and out? The last radio I did, small radio I did, had this swooshy sound to it, and I put it down to a cheap design. So obviously this is terribly distorted. So that's a sign of bad capacitors. A particular capacitor. We'll dig the schematic out. We'll take a look. Anywhere there's a station, or anywhere a signal ends up in the IF, we're going to hear this tone. So, looking for the French station here. What if let's juice up the antenna? How can we do that? Didn't I have a capacitor out? Yes, I did. So, just to be a little cautious. Even I'm pretty good. Here we go. Let's just turn this down a little bit. That I think is the French station right there. I don't know. Depends how accurate the dial is. Okay, we've heard enough. We've heard enough. So, it sounds to me like one of the capacitors whose job it is to stop signals from transferring backwards in the radio, basically, to come through again and start up oscillations and funny sounds. We got to try to find that particular capacitor in here. Usually it's a big one. So, do you see a big one? There's a fair size one down under here, which you might have trouble seeing underneath the special one. We got to find out what the special ones are, what we can do about them, and that's what we got to do first. We got to get the schematic and just go through it. Yeah, that's right. Get the schematic. What, were you looking up at the sky there? What was going on? Yeah, I'm going to dig up the schematic. We'll take a look. Just in case you're new to this game and you've never used Radio Museum to look for information, I'm going to do it here with Radio Museum, and I'm going to wise up and actually search for Philco instead of Philips. Somehow I got it in my head this was a Philips radio. That's kind of crazy, and I've been here for quite a while trying to find the schematic, but in fact it's a Philco radio. So what you do is you just fill out this form here. You put in maybe just the model designation number, no more in there. Maybe you put in the manufacturer, because 25, there's probably a lot of 25s, but Philco probably only made one 25. And then if you want, you can click this box right here. It's off. I'll click it on, and that'll show the search results as photographs. So let's go look. So here they are. There's 3 pages of photographs that search found. Lots of different radios here. But guess what? The very first one in the top left corner is the radio I'm after. Canadian Philco radio, 1939-1940, 25T. So we'll go to the page for that, and we don't get much information here. Philco 25T, powerful AC/DC table model, costly RF stage, and other features included, including attached aerial. Oh, ain't no attached aerial here. There's just a wire here. Attached aerial. The 14T, same fine walnut cabinet as the 25T, AC/DC super heterodyne that gets domestic and foreign shortwave. A real buy for $36.95. Why wouldn't you buy this one and get shortwave at the same price? You buy this one, no shortwave. It's a costly RF stage and other features, including attached aerial. Aerial. So when you say aerial, you usually mean a wire in the air up high. Well, this isn't going to help us. I have to go searching somewhere else. A little disappointed here. I hope to find the schematic here. Okay, I got to go. 3940. Gotta go looking. So this radio is from 1939, 1940, and I have one of these books here. Radio College of Canada, Toronto, Ontario. So you may be familiar with Sam's Photofax. This is something very similar. This was done by a private school called the Radio College of Canada in Toronto, and you could go to that college and they would teach you radio technology, and you can go out and get a job with a manufacturer, or maybe do a repair shop thing, who knows. So what they did at this school was they got versions of radios like this one, the actual radio chassis given to them by the manufacturer. They would then go through the chassis and produce a schematic from examining the chassis. I don't think they worked from the original company's data. I think they actually picked apart the radio. I'm not sure of that. But it was part of the course. Part of learning was drawing the schematics. So a lot of these schematics were drawn by students, I believe, although they're fairly consistent. And then the Radio College of Canada would produce a book every year, and then they would sell this book, another way of making money. And who would buy the book? Guys running repair shops. You had to have a set of these books or something alternative to it. But these were very popular in Canada. I only have this one, but if you had the full set, it's a large amount of stuff. So let's take a look. I already know the schematics in here, so I'm not going to waste time. So we're just going to look through the book and see how this works. Radio College of Canada Circuit Manual, Index of 1939-1940 series. And it gives the manufacturer's name, Canadian General Electric, and the radios they produced. Think about it. Like, this is just 1 year's worth of radios here in Canada. These 2 pages. Yikes. That's a lot of different models coming out into the stores. It's hard for me to even believe that there could be this many different radios available for people to buy. And then along with the Canadian stuff, there'd be all kinds of American radios up here, imported up here, and even European radios for sale too. So, come to think of it, radio was a big thing back then, because what else was there? There wasn't a lot else to spend your money on. So if we look through here, we will find Philco, not Philips, but Philco, Fanola. There's Philco. Philco. There's the numbers. These are the model numbers. Model 10, 12, 14. Come down. Model 25, which is the model I have. And we look across, and it's diagram number 81 under Philco. Oh, my cat is calling me. So here's Philco. Okay, so the way they have this arranged, this is typical. The information is written at the bottom of the sheet because you can do this, right? You can do this thing and look for stuff. So you can see the different manufacturers that were operating here in Canada. And so we'll go to the Philco 81, 80, 85, 84, 83. So here's 81. And there's model 25. Alignment data on sheet 83. Yeah, they didn't want to repeat it over and over for similar models. There's model 25 written right there. This is another model here. So this is it, model 25 right here. Well, that's great. This is the first time I've opened this book, and it's actually worked for me too. Yeah, that's cool. So, I think I need to probably photocopy this and upload it to Radio Museum, since they don't have a schematic. But I've got one. Now let's make sure it's right. So here's the layout diagram, and it certainly matches the radio. Let me grab the radio here. I'm sure this is going to be correct. So you can see, it's matching perfectly. Speaker, IF, another IF, and 2 tubes. They even marked the coil here, and RF tube. So there we are, and we have the schematic. Fantastic. Tubes in series. Pilot light, using a. So the pilot light does not run from a tap on the rectifier, as is quite common. They've done something a little different here with. Can you see that from where you are? You probably really can't see what I'm pointing at, but they have 2 resistors in series here. Looks like 30. I can't really read it right now. 32 ohms and 132 ohms or something in between. And then they have the tubes here. 35Z. That looks like 3. Never heard of that. 35Z5 is what that probably is. And then we have a 35A5E. Well, you know what? These are all Lockstall tubes. Even this one. 35. Well, maybe I can read it over here. 35Z3. Okay, I guess that's the Lockstall version of it. Excellent. Somehow I gotta get this. Well, I don't know what to do. What are we doing? We're having a coffee. We're having a coffee. I'm going to look this over while I drink some coffee and deal with my poor cat, who again wants to go outside. While I was drinking my coffee, I was listening to Noam Chomsky, one of my favorite guys, talking about AI. And here's what he pointed out about AI. He's got a completely opposite view of it. Well, the whole world is going, AI's coming, AI's so smart, AI's taking over. He pointed this out. He goes, AI is as stupid as can be. You probably know this, that AI is a system which determines the next word in a sentence. That's what it does. It determines the next word. That's what it's working on. And it's really good at it. It's really good at it. He pointed out that those systems, AI systems, use huge amounts of data to get themselves to where they are. But if you think about a young child, a very young child, around the age of 2 or 3, by that age they have mastered the basics of language. And they have been exposed to what? Goo goo gaga and a bunch of babbling adults, and some regular language being spoken around them. No one's trying to teach babies language, yet they learn it. And it's called a paucity of information or scarcity of information. I can't remember. The baby operates with a scarcity of information, whereas AI is using everything it can get its hands on to sort things out. So his point is AI, dumb and stupid, and that's the way it's going to stay. That was his point of view. Okay, totally opposite from what other people are saying. But I really like Noam Chomsky because, man, he operates from a base of knowledge that is so broad that every when I find when he talks, especially about history, he has a perspective which is different from everybody's, but it all makes sense because the man knows so much. Oh my gosh, Noam Chomsky. Okay. Now I'm all excited about that, but let's look at this. You've been looking at it while I've been babbling here. So we want to find these special capacitors. Let's see if we can spot them in here. Some kind of special capacitor. Is there maybe there's a note? Location of compensators. This radio's got compensators in it. There's the two filter capacitors. Oh, interestingly enough, it says 60 microfarads and 40. And the capacitor I took out was a 4040. And I put in 4747. So we're in the ballpark. You know, these don't need to be so large when you have a field coil. And there is a field coil. Yes, it's definitely a field coil in the speaker. Hadn't really noticed that earlier. Okay, but this isn't finding us the capacitors in question. So I think here it is. Here's one of them right here. So it gives number 8, but it doesn't. There's no list. Is there a parts list somewhere? There's no parts list. Shoot. Well, there it is though. You see, it's a capacitor with a coil. And I believe the idea is this is resonant at the IF frequency. I believe. And the benefit of that is it somehow it avoids a detrimental problem of just putting a capacitor here or a capacitor and a resistor in this position. And what position is this? They got something, so they've drawn this a little weird. That's number 9. There's no dot there. There's a dot there. There's a 0.02 here. Where's this line going? It's going everywhere. I must be on the B plus line here. Is there a dot there? Here it is. So it's coming out of the power supply. There's the B plus. Connects here. Goes up through here to reach the plate, which is normal. Up here through a fairly large resistor. Yep, there it is. 220K resistor. Plate supply. Another plate supply through the IF transformer primary. It's another probably screen supply with a big resistor. And a capacitor here to filter the screen. Is this the screen? Yes, it is. Good. And then this is probably the other screen. Double screen. Oh, wait a minute. That's not a screen. Well, maybe there's no suppressor in here. That must be the case. No suppressor. No, this is one of those seven tubes, one of those octal tubes, and it may just be a little different from anything else. Kind of going through this backwards. There's another screen coming out here. So on these screen and plate circuits, there should be a capacitor on the screen circuits anyway. Let's go back to this one. Did I miss it? There's just this one. 0.05. It's not very big. 0.05 to the cathode here. So the sound we were hearing when I was tuning, and we were hearing this high-pitched sound as you tune in a heterodyne tone. It could be this capacitor that's responsible for stopping that. Let's look at the power supply here. There's a cathode in the rectifier tube. small capacitor right across the power line here. And this capacitor is energized anytime the radio is plugged in. So no doubt we'll come across that. I wish I could find the parts list. That would help a lot. What am I doing here? I'm looking for a big capacitor that's quieting the screens. It's got to be that one, the not so big one. And this one over here is very small, 0.006 micro. Looks like micro. What? No, can't be micro 0.006. What have they done here? I'm not sure what they wrote there. I can't see it. You can't see it. I can't see it either. It's too small. So the best thing to do with this for now is just leave this alone. I think most cases, if somebody's interested in replacing this, I mean, you can rewind these things. These are specially tuned, so they have to be wound exactly, to do the job. Or you just put another capacitor in here. Don't sweat over it. All these radios come with the ultimate compensator, the volume control. So if your radio is depleted in strength, the volume control compensates for it. You get the same volume in the end, and everybody's happy. So I don't know how valuable this is, but you can see what did they put in that sales brochure? Special RF front end. Let's look at that. So what are they talking about there? So this is the mixer tube here, and this one is an RF tube. So this radio has come with a front end RF tube, almost certainly tuned circuits on either side. And look at all of this is missing in this radio. This is a big problem for this guy. Where's the antenna? Or am I misinterpreting this? Yeah, I'm misinterpreting it. This is the coil on the radio, and there's the wire hanging out the back. They show this going to ground, but there's no obvious ground wire. And you see how the antenna and this would be actually electrically separated, except for the transformation action here. They aren't actually connected. They're using the ground symbol here, the same symbol they're using all through the radio. And what is this? Can you see that? Yes, you can. There's a little tiny coil sitting there. What the heck is that? It's just there. So I don't know what this trick is. This coil on the radio. If we just look over at the radio for a moment, you can barely see it. It's sitting right here. Pretty sure that's the coil. In my mind, to a large degree, these radios are these coils. Transformers that are built are designed by the engineers who are designing these radios, and number of turns, all that kind of stuff. And these are very specific to this radio. This coil is for this radio. This tube can go on numerous radios, tubes, capacitors, but these coils, I think, are the identity of these radios to a large degree. Yeah, the overall circuit too. Oh yes, of course. But and I keep babbling here in hopes that something interesting will appear in front of me. So let's take a look at the situation with this. What is this all about? So the showing coming off the cathode to, I assume this must be a chassis connection. Well, what else could it be? Must be a chassis connection. So this capacitor, which I think is the one quieting the screens, stabilizing the screens if you like, doesn't go right to ground. It goes to ground through another one. And that looks like a 0.02 there, which I can't read right now, and neither can you. This is a 0.05. Let's follow this. Maybe there's more. Oh, there's all kinds of stuff on this wire. Oh, yeah. What is going on here? 150 ohms. So there's a cathode resistor for this tube to provide the bias. This line must be shown going up here because it's catching something. What's it catching up here? It's catching there's no shields on this radio, and these are not metal tubes. Don't know what this wire's doing coming up here, but I'm not going to worry about it. Let's take a look at how the output tube gets its bias. So we have the output tube grid here, okay, fed from this capacitor, which is probably leaky. So the grid is probably being pushed positive. We can look at that later. Come down through the cathode. Yeah, there's a 150 ohm resistor sitting there in the cathode circuit. So it's cathode biasing, which is extremely common way of doing it, especially with the output tube. These other tubes, not so much. But this front one, yes, they use a cathode bias on that. So these tubes are probably, I was going to say, let's look at the AVC circuit. Might as well look at everything while we're here. So here's the two diodes in the detector tube. And what are they doing? So one is coming down to here, and the other one is connected up here. This is a large resistor. What's that say? 22 meg. There's a gigantic resistor here. So it's really two separate circuits. So let's follow this one that's going through the transformer. This is probably the one that's carrying the detected audio or rectified audio. Sure enough, right down to the volume control and a capacitor here, a small capacitor, bleed off any RF and dump it. Dump the RF that might be there. And no other connections anywhere. But if we follow this other one now, on the other side of the gigantic resistor, this one just kind of bypasses all this stuff and heads way over here. And this is going to come up, go through the coil and reach a grid. And we're going to come along further. There's no, is there a dot there? That looks like there might be a dot here. So if there is a dot, there's a connection, then we can carry on through a large resistor, 2.2 megohms, up to this grid. And we would also go this way. There's a 0.05 capacitor to through this schmozzle. This must be B minus here. This line, I think that's a dot there. It's hard to say. They really didn't heavy up the dots on this. But I'm going to bet it's a dot. So this is probably the AVC capacitor that's charging up and discharging if it's on the far side of a big resistor. The far side, well, again, we're coming down here, we're bypassing the big guy here. No, there's no big, no big resistor. Usually there is a big resistor in this part of the circuit. Anyway, there isn't, so that's okay. Later, when I want to do the alignment on here, I can hook up. I can probably hook a voltmeter right on this line without much trouble, but I could also probably pick off a DC voltage at the top of the volume control. Now look, they're letting the DC, the rectified signal here, go right through the volume control to reach ground. This is 500,000 ohms here, and then you could get a little bit of DC charge going doing this thing. This is usually a really big resistor. Yeah, 4.7 megohms here. It's just a gigantic resistor here. And that means this circuit is very, very high impedance, if you like, or high resistance. It's that. It's about 5 megohms here, which means a small charge pumped into it causes a large voltage change here. So if this guy leaks just a little bit of voltage, just a little bit, you might throw the biasing off here. I'm making all this up, by the way. I mean, makes sense to me, but is it really true? Does it really work that way? Well, that's why I fix these radios, to find out if what I got in my head is crazy. What have I got in my head that's crazy? I think okay, so maybe I've made all the observations I need to make at this point with this schematic. And is there anything else? Tubes are all in series here. So these tubes, heaters, are in series with these two resistors. You know what this is? This is that big resistor stuck on the side of the chassis. That's what this is. Parts list would help. Okay, oh, we should make a note of that. The IF frequency for this radio is 460. Alignment data. Is there parts on sheet 83? I don't think so. No, it's just the alignment information. No parts list. Okay, that's good. I think we're ready to go. I can close the book on this. Yeah, let's just take a look at this book. Look at the front part. Let's just look at the back part. Is there something special back here? It's a Ford Philco. Where did I get this from? The Ferguson radio service. Service you appreciate. All types of radios serviced and repaired. Leslie J. Ferguson, proprietor. Phone Meaford 288. The phone number is 288. That's it. 288. Wow, how old is this piece of paper? IF 460. Okay, what else we got at the back of this? Just the last page. Nothing special back here. Just I thought there might be some secrets at the very back of the book. There isn't. Okay. That's great. I have a write-up in my house, a handwritten write-up on how to convert CB radios. I can't remember what the conversion was. Some kind of conversion of CB radios. I should find it. It's 10 handwritten pages. It appears to be off the top of somebody's head. It looks that way. It's hard to believe because it's beautifully laid out and written by somebody who really knows what they're talking about. All handwritten, and I have it. And I've been looking for relatives of the person who wrote it, and I haven't found them yet because I want to send it to them and say, look, your uncle wrote this amazing thing. If I find it, I'll bring it in here and just flash it on a video. Of course, you won't know what the heck I'm doing, but that's okay. So we want to find that 0.05 capacitor. Oh my gosh, how are we going to do that? The one that's yeah. So I'm going to go on the hunt for that. One way is we can see the size of these. This is a 0.05. This is a 0.03. This one is we don't know, but anyway, those kinds of things can help too. Good luck to me. I'm going to try to find it. Okay, well, this is going to go a little bit by elimination, I think. So one of the capacitors of interest here is the which one was it? It was the oh, for crying out loud. Well, we'll work backwards. So this one here that I can clearly see is a 0.03. One side is connected to this resistor, and the other side is connected right to the power switch. And you can see a black wire. That's the power cord, Jim. So if we look here, oh, I remember now. There's the 0.03 there, right across the power. Let's see if we can see that here. So we see, oh, we can see it clearly. So here's the power coming in, these two wires here. One goes here, there's the capacitor, and the other goes there. There's the other side of this capacitor. So this capacitor is right across the power line. Plug in the radio this guy is taking a beating. Well, maybe not a beating, but it's taking it. Doesn't matter whether the radio's switched on or off. So that one we want to change for sure. But the one I'm really after is this guy, and this guy. All three of these. So 1, 2, 3. Well, how many are there in here? Okay, exclude that one. You can exclude this one. This is the volume control one. So, 1, 2, 3, 4. I don't know why. This must be. I don't know what's going on here with this parallel capacitor. That doesn't match the schematic. And we have these ones up here. Yeah. So one of those is it. This is a 0.05 here. Yeah, back to me just quietly looking on my own thing. I'll just do this on my own here. So it looks like on this schematic they use this ground symbol that you see here and there to mean two different things at different times. Not good. This connection here is definitely a connection right to the chassis, and you can see it. It's just over here. It's this thing right here. This is a lug that's riveted to the chassis, and these special capacitors are connected to it. There's also a wire that runs to all the grounded elements or chassis type elements of the tube sockets, which is mainly the center post. Just runs through the radio doing that. There's no other connection to the chassis in here that I can spot. Just this one. So what they're doing then for the B minus is they have a circuit in here, a wire in here, type thing. So that's the only one I can find. Yet they're all over the place in this schematic. Okay, I was busily talking about the schematic, and I bumped the camera, and it was just looking at nothing. So let's go through this again. I hate doing things over when I'm working in my shop here. I don't like it when it happens. So what was I doing? So I was examining this ground symbol and noticing that it's showing up all over the place here. There's one here and one out here. Some of these I can explain fairly easily. Let's start with this one. This one is visible in the radio. It's right here. That's a lug right onto the chassis, and it's riveted right on. And these are the special capacitors with the coil and the other Philco stuff. That's this guy here. So that's what that is. There's no question. That is a connection to the chassis. These two and these two probably represent the tuning capacitor frame. And it's probably bolted right to the chassis. Let's take a look. Let's see what's going on here. Okay, so here's the frame, and as dusty as it is, it's a very curious thing done here. That's a little kind of a fancy deal here. The other side looks like a solid metal plate with rivets and other stuff. Pretty sure this is tied right to the chassis, and that's what those symbols are showing. And it's a little bit common in these radios to have the front end joined up by the chassis, and I don't understand this, frankly, why this happens. But so that explains those two. These two are the same thing. This one we've seen. This one, well, it's coming out of the complicated antenna coil, but if we look, we'll probably find a wire that goes to the chassis. I've done it again. I keep failing to re-aim my... sorry about that. I'm not going to stop. So these two symbols are the frame, of the capacitor. These two are the frame of the capacitor. That's the lug we saw. This we could probably find. It's probably near that antenna coil. Probably find it. It's this one that I'm curious about. This is coming off the cathode. Isn't the cathode tied directly back to B minus? So we follow the B minus line here. No dot, no dot. There's a dot there. So we have B minus tied to the chassis through this capacitor. What's this other one doing? Isn't it doing the same thing? Let's follow the B minus further. Here, we come to here, to where? To here. Come along. Wait a minute. We don't attach here. Oh boy, we attach here. We shorted the power supply right out, so there's no dot there. There's a dot here. So we come along, passing this capacitor and questioning. There's a dot here, so we're coming across. Now we're on this line. Here's another capacitor here. I'm getting quite confused. This is the line that's tied to this guy. So this guy, and I've totally lost it. What are they doing here? What am I doing basically? I'm trying my best to figure out what capacitor does what and replace them in an order, and then examine or test the radio, find out what happens, and see if what that capacitor was doing. That's kind of what I'm trying to pull off here. It's not going well at all. I might just switch to the like for like. Just pull out a capacitor, see what its size is, and put another one in the same size and carry on. As opposed to trying to analyze this. Why are they doing that? Why would you do that? See, they're using this capacitor to quiet down the screen line. And it's going from the screen to the B minus. And the B minus is connected through this capacitor. The B minus is also connected through this guy. This is a very small capacitor. You know, this is a resonant thing, but this is not. Because this is the main this is the main thing. And what's this guy doing over here? They're doing the same thing, aren't they? Ground symbol, ground symbol. Connect to this wire. They're doing the same thing. They're in parallel. They're in parallel. The two capacitors are in parallel in the radio. Okay. So they've actually put this capacitor, not here. They've put it right here. Right beside this one. Physically in the radio. That's what I'm seeing. So I should change this one. We'll just leave this one. That's probably the best thing I can do. Okay, so that explains the two capacitors strapped together over here. This arrangement here. The schematic is kind of, the way they've drawn it here is for the sake of the drawing, not for the sake of me trying to sort things out in the back of the radio. So this is quite misleading, but now I got it figured out. So this is the same as this, functionally. They have this resonant thing in here, and I can't tell you exactly why, but I think it has to do with avoiding accidentally draining out the IF, but I don't know. So if we want to try to solve the heterodyne tuning tone, we got to go after this guy. This is the guy. Now I know where he is in the radio. Okay, we're going after it. I got somewhere. Yes, it took a while, but I got somewhere. So we're going to go after this capacitor and replace it. And then we'll test the radio and see if I'm a crackpot. Okay, So I've taken out two capacitors. One is the 0.05, the one that I think is potentially responsible for the oscillations that we're hearing, if I can call it that. And this one, which was the one that was right across the power line. Or if I got them backwards. This big one is a 0.03. The small one is a 0.05. Wait a minute. I think that says 0.03. Wait a minute. Sometimes you can scratch off the dirty wax and read the print underneath. Sometimes you can do that. 0.02. 0.02. Well, 0.02, eh? Let's see. Yeah, that could be 0.02. Okay, we got a 0.02, and I put in a. What did I put in there? I put in a 0.0. Ah, who cares? I put a capacitor in there. You know, I'm not sure the size is terribly critical. Okay, so two new capacitors in there. Yellow one here. This is the one that's across the power line. I wanted to get that changed right away. And then this one is the filtering one, who's I may have put a bigger one in than what was in there originally, because somehow I thought it was a 0.05. Yeah, I put a 0.05 in there, but let's leave it. We're going to check these. Let's test these guys here. We'll test them over here. Okay, let me just put this like this. There we are. Okay, magic eye coming on. So what this tester will do is it will put a high voltage, a voltage of my choice, on the capacitor, and it will detect any leak of DC current through the capacitor and reflect it on this magic eye. If no current's flowing, like right now, the eye is open like this. When current flows, the eye closes. After the capacitor charges, if there's still current flowing, the eye will stay closed or closed to some degree. Otherwise it will pop open like you see it now, even bigger. So here we go. So we're starting with 50 volts. If you put 50 volts on this capacitor, does it leak? The answer is absolutely yes. So the eye is not opening at all. So that's no good. And now we will. So that capacitor is across the power line. Anytime that radio was plugged in, this capacitor is sitting across the power line. Now a good capacitor on the power line, it doesn't mean much. It might just help the power company a little bit with phase angle, a little tiny bit. But it's on. This one's already got a certain amount of leak through it. In the long run, something like this could burn up. It's hooked right up to the nuclear power plant through the power cord. So if you had an old radio down in the basement and you leave it plugged in all the time and it's got a capacitor, not all of them have this, but some have a capacitor like this, that thing is actually energizing a component which could fail in your basement while you're sleeping. That would not be good. Okay, so to do the test now, I've done the test. To do the test, I've changed the capacitor. What am I doing? I've lost control of myself here. So this one, the thing, I can see a slight opening here, but this is only 50 volts, so this is showing as a very bad capacitor. Any surprise on that? None whatsoever. The surprise would be to find it not leaking. Now if I put a brand new capacitor on this tester and do this test, the eye will pop open all the way up to 450 volts over here. The eye will pop right open on a brand new capacitor. There's no question that that test certainly indicates stuff. Okay, so we're ready to try the radio out again. We'll see if it performs any better. It was making a swooshy sound as we tuned through stations. didn't like it too much. Okay, so switch on, volume up a little bit, power plug back in. Okay, dim bulbs going. I think, as I said, I think I said in the last video, I think I'm the guy who's make dim bulbs popular again. Here we go. This one glowed a little bit, but all looks fine. The capacitor across the power line, you might be wondering, well, why is it there anyway? And a couple of reasons, but one of them is to stop any radio signals from coming in on the power line or from going out on the power line, for that matter. And the other one is to help with the grounding of the radio, and I am not too sure about that, so I don't want to say too much, but I think because the cord is unpolarized, one side of the line is grounded, and to get access to that ground under any circumstance, there's a capacitor across the line. I think. I don't know. That sounds pretty good. Let's see what happens when we tune something. Oh, it's still doing that. Still doing exactly the same thing. But it sounds better, doesn't it? Okay, so I'm going to give it a little more antenna. Give it a lot more antenna. So I'm going to clip this just to the insulation on the antenna wire. It's not actually connected yet. It's just close. Like a poor man's capacitor there. That's not good. Well, there's still something wrong here. That sounds pretty bad. Okay, well, that's it for today. Radio not working. That's okay. One step at a time. I like doing this capacitor by capacitor thing, and when you hit the mark, you'll learn a lot of stuff. So that's what I'm trying to do here with this guy. Hopefully this thing I can leave in. It's not having any influence on the radio. And this Hunt's capacitor, when we get to this one, I'll be able to do something quite interesting in my shop here when we get there. And we will get there. Okay, well, thanks a lot for watching today, and enjoy your day. It looks like weather forecast here was cloudy all day, but it's been sunny all morning. So I don't know how that works. And the weather here is pretty warm, 24 degrees. That's quite comfortable. And we're getting lots of our fall yard work done, all our gardens and stuff like that. My wife and I are working on. So good weather is really helping out. Thanks a lot for watching, and tomorrow we'll just carry on doing stuff. See ya.